It is time for the final video of the IB Chemistry 2025 TZ2 Paper 1A HL walkthrough series. Even if Al is hyped, you can hear my cat meowing in the background if you listen hard enough. Anyways, starting with question number 36. This is 36 through 40. So this one is, in which compound does sulfur have an oxidation state of +4? Very basic. You literally just have to calculate the oxidation state of sulfur in all of these. Okay. So for A, you have H2S. Hydrogen is 1. So you have 2 times 1 plus S. It's overall going to be 0. Okay. So you got sulfur is equal to -2. Okay. So that is not +4. Wrong. B, sulfur plus, and you've got 3 oxygens. Each of them has an oxidation state of -2. Equal to 0. Bang, bang. Okay. So you have S is going to be equal to +6. Crazy. Still not +4. So wrong. C, you have sulfur +2 because there's 2 hydrogens. Each of them is +1. Plus 3 times -2 is equal to 0 because the compound's neutral. So you got S plus 2 minus 6 is equal to 0. Now, y'all gonna make fun of me for this, but I count on my fingers. Okay, so you have -6 plus 2. That'd be -4. So that would be +4. Yeah, sulfur. So C would be the right answer here. But we're going to solve for D, because if D is also right, we're screwed, right? So we have S plus 2 plus 4 times -2 is equal to 0. So that'd be sulfur plus 2 minus 8 is equal to 0. That'd be sulfur is going to be equal to +6, which is also not right. So C is still the correct answer for this number 36. Math. Okay, question number 37. This is about standard cell potential. Okay, and it's of this voltaic cell. You've got these nice E cells, which is funny because you have the data booklet. Anyways, but it gives it to you anyways, so you don't have to flip through. So that you have the silver and you have this magnesium. And so silver is going to be more positive. Meanwhile, this magnesium is going to be more negative. The more negative that value is, the more likely it's going to be oxidized. Okay, so we're saying that magnesium is going to be oxidized. Okay, and oxidation is loss of electrons. Oil. Okay, loss of electrons. Okay, and so we're going to reverse this equation. So we've got magnesium forming that Mg2 plus and those 2 electrons. And so that E would then be plus 2.37 volts. Okay. And so then you have the silver that is going to be more positive, and so that's more likely to be reduced. And so the reduction is the gain of electrons, and so that equation is going to stay the same. And then you just add them together. Cool. So you've just got that plus 2.37 plus 0.80, because they're both in the right direction. And so that gives you that is going to be this plus 3.17 volts. And so 37 is going to be D. So which change for number 38? Sorry, I forgot to say that. Which change represents oxidation of the functional group? Okay, so if we're thinking oxidation, right? Oxidation is, I kind of like to make a chain of oxidation whenever I'm thinking about it. Okay, so you've got your alcohols, and then you've got your aldehydes, and then you've got your carboxylic acids. Okay, and so oxidation is going from left to right. You have your general definitions of oxidation, reduction, whatever. With organic, I like to think of it the Leyden Blue textbook, my favorite organic textbook, by the way. I believe defines it as the more bonds you have to heteroatoms, the more oxidized it is. And so like for instance, in an alcohol, you have just one carbon to oxygen bond. Meanwhile, in an aldehyde or a ketone, you have a double bond, so that's two bonds. Meanwhile, in the carboxylic acids, you have that double bond and that single bond, so that's three bonds. So the most oxidized. And I feel like that's the best way to kind of think about it and remember it. So you're looking for something that's going from left to right here, TLDR. And to do that, you have to kind of recognize the function groups and the formulas. Okay. So obviously, like an OH, like a COH is going to be like an alcohol. An aldehyde tends to be denotated as CHO usually. And then COOH is a carboxylic acid. These may differ. And so we'll see how. Oh, where am I? Going back. Okay, 38. So in this A's, we have the COOH. So it's going to be a carboxylic acid. I'm going to put just CA. I'm lazy. And then CH3CHO. So it's going to an aldehyde. Ald. Okay, so that's not going left to right. That's going right to left. That is a reduction. So not bad. Wrong. B. H2CO. You may be thinking, what? And so CO, oh, H's on the sides. This is just formaldehyde, okay? So that's an aldehyde. So we're going from an aldehyde to HCOOH, carboxylic acid. So that is going from left to right. So that is an oxidation. So B is right. But we're going to check C and D. We're always going to check it. So C, HCCH, HC. H. Carbon likes to have four bonds, so this must be a triple bond. Crazy. Meanwhile, H2CCH2. I don't know where to put these other hydrogens. There we go. So we're going from an alkyne. Crazy. We rarely see those. And an alkene. So that is another one where that is going to be a reduction. And so that is not right. And that one you can think about in traditional oxidation reduction, gain or loss of hydrogen type of terms. D, H2CO. Once again, we already established that would be an aldehyde. So ald, 2CH3OH, alcohol. Alk. You turn. So that one is once again going from right to left. So that would be a reduction. So that would be incorrect. So B is the right answer here for 38. Okay, so this question number 39, second to last question is we got what are the products of the electrolysis of dilute aqueous copper 2 sulfate when using inert electrodes? So the inert electrodes bit is telling us this is not electroplating. It's like, so we have competition at each electrode because in addition to our copper sulfate, so our CuSO4, we also have water. So we have in our races, we have OH minus versus SO4 2 minus. And then we're also going to have Cu2 plus versus what's the word? H plus. Okay. And so in order to tell which is which, so think about this. So we have our anions and our cations kind of paired together. So our anions, negatively charged, they're going to be attracted to, they're going to love the positive electrode. The positive electrode for voltaic cells is normally the cathode. And I feel like that word just sounds positive. I don't know if its etymology is. I don't know prefixes, suffixes. Anyways, it feels positive in my brain. And so I always just think electrolysis is opposite day. So the positive electrodes would be the anode. Okay, it's the opposite day. And so anode and then N X is we're going to look for the more likely to be oxidized. Okay, the reverse is over here is the cathode for the cations, and then red cat. Okay, so it's going to be looking for reduction. So normally you want to go to the data booklet and you want to look at OH minus to form oxygen gas versus SO42 minus to form question mark. And so you may be tempted. So you would look at this 1.23 kind of equation. There we go, there. But you may be tempted to look at this equation right here with this SO42 minus. However, SO42 minus should be being oxidized, not reduced. In this equation, SO42 minus is being reduced. So this equation isn't even relevant. We actually don't even have the equation for SO42 minus being oxidized. which is kind of stupid in my opinion. But anyways, and so basically what that is telling you though is that essentially no matter what, oxygen gas is going to be produced. So boo boo SO42 minus oxygen gas is going to be produced at the anode. So that immediately puts us for A and B as our options. C and D are diluted. Meanwhile, for the product at our cathode, we have Cu2 plus versus H plus. So we're either going to be forming copper solid or hydrogen gas. Okay, so we're going to go over to our data booklet. We're going to look for our equation with forming hydrogen gas. And so that's going to be our minus 0.83 versus our Cu2 plus to, there we go. So plus 34. And so since that one is more positive, it's more likely to be reduced. And so we're going to be forming copper metal instead. Okay, so boo, hydrogen gas loses. We're going to form copper metal. And therefore, that is why B is the correct answer. Okay, and so you're going to be looking at the electrode potentials. The only time you don't look at the electrode potentials is whenever you have a concentrated solution of something with a halogen in it, in which case the halogen would be produced as a gas. Other than that, you're going to look at the electrode potentials. And we don't even have one for SO42 minus because God said so. I don't know. Yeah. Okay, and finally, last but not least, we have question number 40, which is which equation represents the propagation in a radical substitution mechanism? Okay, and so the big thing you should notice here is the fact that it is a propagation step. Okay, and so propagation steps always have a radical reacting with a non-radical to produce another radical and another non-radical. Okay, so there should be roughly 4 things reacting. Wow, my handwriting is terrible there, but we're gonna ignore it. Okay, and so whenever we look at these, is A, we've got non-radical, radical, radical, non-radical. Looking interesting. Mayhaps. Okay, gonna look at B. B, radical, radical, non-radical, bad. Boo. That is actually a termination step. C, you've got a non-radical, my lighter, non-radical forming two radicals. That is the initiation step. So also incorrect. Meanwhile, D, you have radical, non-radical, radical, non-radical. Look at, and then you see, what is this H radical? What in the hell? Am I allowed to say that? I don't know. What in the heck? That's disgusting. No, okay. And in general, you have in this reaction is you have the CH3Cl, and you are forming, you're exchanging a hydrogen for a chlorine. That's not what's happening. Okay, that's gross. I don't even know if that's possible. Okay. Meanwhile, in that A, you have that, call it alkane zombie radical that's being formed. Because you always have in your propagation step, you always have your alkane reacting with your halogen radical to form a kind of alkane zombie radical that then goes on to react with your halogen to form your halogen alkane, if that makes sense. And so that one makes sense, and so that one is A. And that is the end of this godforsaken exam. You did it. You did it. And now you have to go look at 1B in paper 2, which will take me another like 10 hours to film. Good luck.